During this video, I'm going to walk you through Wire Triangle Special Part 1 and Part 2. Please make sure that you have a small protractor. You also need to grab a ruler, so if you need to hit pause, grab a ruler. And your group should have one bag of geosticks. After you all are done with questions number 1, you can put those geosticks back in the bag and return them. I'd like you not to be making a mess with them and fussing with them when we don't need them today. So let's get started. If you have all those supplies, question number 1 states that we need to grab 3 geosticks and form a triangle. I'd like you to grab 3 different colors. On the geosticks, remember that there are 2 numbers. The smaller number is the distance between the little plastic knobs, and the larger number is the whole length of the geostick. So once you have that triangle made, make a sketch of it in this area and label the sides. To complete number 2, I want you to pick up the same 3 colors. Pick up the same 3 colors, and I want you to form a triangle that is not congruent to the first. Try to rearrange the colors and see if you can make a triangle that is not congruent to the first. As you're going through this, I think you're going to determine that you cannot. Triangles are what we call rigid. You can't push on a vertex and create something different. With just 3 sides, you get what you get when you have the same 3 colors. So what we guys and gals have just established is that there's a shortcut for proving congruence, okay? So we had limited information. We had that the 3 sides were the same. Side, side, side. You had 3 colors that were the same. And it showed that if the 3 side lengths of 2 different triangles are the same, then the triangles have to be congruent. The definition of congruent is that all angles and sides are congruent. So this is saying if I just give you a single, I just give you the sides, then we can prove that these triangles are congruent. Okay. So we are moving on to number 4. Okay, number 4 is to use the geosticks to form a quadrilateral. Make a sketch of the quadrilateral below and label the side lengths. So as I'm going through this, obviously I'm not making these with you. You need to hit pause if needed and then continue to the next step. Okay. So then to do number 5, what you're going to do is pick up those same 4 colors and see if it's possible to form a quadrilateral that's not congruent to the first. Again, hit pause right now if you need to. Okay, so we have the quadrilateral drawn, and if you were to take that quadrilateral and just push on one corner, you could create a totally different quadrilateral. So the same rule that we just established for number 1 and 2 and 3 for triangles did not establish, we did not have the same rigid properties. So our conclusion here for number 6, if the 4 side lengths of 2 quadrilaterals are the same, then the quadrilaterals are not necessarily congruent. Now, they could be congruent, but if I don't tell you anything about the angles, they don't have to be congruent. Okay, because if I have this quadrilateral, there's nothing preventing me from, if I push on this angle here, I can create a totally different looking quadrilateral that then is convex or concave and it just pushes in easily. Okay. So the next part, we are now done with the geosticks. If everybody in your group is done, you can put them in the bag and put them back on the kidney table. Okay? So when you are ready, you can hit pause and clean up if you need to, and then hit play when you're ready for the next question. All right, so on question 7, use the line segment below and draw a 40-degree angle at point A and a 60-degree angle at point B. So you're going to take your little protractor, okay, and you're going to place it on point A, right here. So you place your protractor on the crosshairs or the hole on this point A, and we want a 40-degree angle. So you take your pen or your pencil and you put a tick mark at 40 degrees here. We don't know how long this side is going to be, okay? But then you grab your protractor and move it over to point B, and we want a 60-degree angle. And so we're going to find 60, and we're going to place a tick mark here at 60. And so then move your protractor out of the way or use it as your straight edge. What you're going to do is you're going to use your ruler or your protractor and draw in the line that extends through the 40-degree tick mark here. And then, let me undo that. Then I want you to draw in, it won't let me move my protractor out of the way. There we go. Then I need you to draw in the line from point B. Oh my goodness. Now I want you to draw on the point, the line from point B. Okay, now we have to make sure, I want you then to double check, did you get 40 degrees in this angle and 60 degrees down here? And so we have limited criteria that we're starting with. We're starting with this segment AB here. And when I measure that, I'm getting 8.7 centimeters. Okay, don't round to 9, but we want to keep this exact, so 8.7. And so what you're going to do is measure all the sides and the angles and compare with everybody in your group. If everybody in your group has angle, side, angle, the same, does that force everybody's triangle to be the same? That's what you're exploring here, okay? So hit pause, measure all the angles and sides, and see what you get. When you're done, hit play, and I'll share the answers you should have. All right. So as I went through here, I got 40 and 60. Of course, then when you measure this angle, it had to be 80 because of the 180 degrees here. This side length, I got 7.7. This side, I got 5.7. If you got 7.6 or 5.6 or 5.8, you're just 1/10 off. That's fine. But I hope you would realize then everybody in your group got congruent triangles because of this angle, side, angle limitation. So the conclusion here for number 9, if two triangles have two corresponding angles congruent and the side in between them is congruent, the triangles must be congruent. So this isn't a shortcut for us for triangle congruence. So we have one more shortcut here on part 1 to go through. Are the triangles below congruent or not, or is there not enough information to determine this? So what do we have listed here? We have an angle, and a side. Angle, angle, side. And we are going to write angle, angle, side because this side is not in between these two angles as in the previous one. So this side the side either has to be listed first or last. And they are the exact same thing, but we just usually list it here alphabetical. Okay? So we have angle, angle, side. Now, use your protractor, measure the third angle, then measure these other two sides. When you are done, hit play. All All right, so using the millimeters there on your, or centimeters on your protractor and ruler, you should have got 5.1 for this side, 4.0, 5.1, and 4.0. And so that is showing you if we have this angle, angle, side limitation, the triangles then were still congruent. Okay, and that's our explanation. This is number 12 right here, that the triangles are congruent. Okay, now on number 11, explain if two triangles are if two angles in a triangle are congruent to two others, then why must the third angles be equal? And we've talked about this a couple times in class. If I know two angles, like 30 and 110, then my last angle here, this is going to be 140. My last angle here of 40 degrees in both, they have to be congruent, okay? Because this triangle equals 180 degrees, this triangle equals 180 degrees. So this says, in the sloppiness here, it says because, so the abbreviation B/C, because all triangles sum, and then it says 180 degrees, okay? Because all triangles sum 180 degrees, if I know two angles, I can easily determine that the third ones are equal or congruent. So that concludes part 1 for wire triangles, special part 1. I'm going to go ahead and pause and create a new video for wire triangle special part 2.